Oi, hola. Eu falo francês, eu falo inglês, eu não falo português. So I'm sorry, but I'll switch to English because that's pretty much all I can say in Portuguese. Plus a few other things like food and stuff like this. So today I'd like to tell you about choreography and orchestration, different approaches to microservices. And especially towards the end, I'll focus more on best practices, patterns that you can apply in this area. So my name is Guillaume Laforge. I'm a developer advocate for Google Cloud. And as such, I will be showing some Google Cloud products, obviously. But the advice we give here are usually meaningful for other environments and other products. So don't be too tied to the fact that I'm showing, I'll be telling you about a product called Google Cloud Workflows. But it's not just about workflows, even if I introduce the product later on. So what I mean by choreography or orchestration, so I'm not going to do like a ballet, or I'm not going to conduct some kind of orchestra, but instead we'll speak about those two words in the context of how you organize microservices together. How can those microservices cooperate together toward a common goal, towards creating some business transactions, some business processes, etc. For that, there are different approaches. So let's say, first of all, you went from a monolith to a microservices architecture. But then how do those microservices interact with each other? So one naive way could be direct service-to-service calls. So let's imagine this example where you have some kind of shopping application with you've got some kind of front end here, a web front end, that calls a backend to authorize and charge credit cards, a payment processor. Then, if it's successful, it's going to call another service directly, synchronously. That third service or second service will be going to ship the products that you've ordered. And then perhaps one last service that would be called from the shipper service to say, okay, I'm going to notify the customer that they will receive their parcel, their order, at some point. So it's easy to do that kind of service-to-service calls. I'm going to show you some pros and cons. So it's easy to implement because it's just let's say an HTTP call or remote procedure call, depending on the technology you use. It's fairly straightforward to implement. So it's a good thing. However, there are probably more cons to this because there's definitely too much coupling because the first service needs to know exactly how the second service will work. And there's a chain, in my example of services, a very linear sequential chain. But then each service in that chain might be a single point of failure. Because if something fails in the middle, the shipper service, then you're not sure what's going to happen with the rest of your business process. And also, each service that calls another service needs to handle properly things like errors, retries if the service fails, timeout logic, maybe if a service takes too much time to respond. And also, who really ensures that the whole business transaction is successful? So somehow we need some kind of good microservice that would be able to see what's going on through that invocation chain. And we'll speak later on about a pattern called the Saga pattern, which is a way to handle things like compensation operations for bigger business processes. Another approach, still the same use case. So it's an event-driven approach. So that's also what we call choreography of events, etc. So you still have the same services, the same front end and the same services, but instead they're going to use some kind of message broker. So whether it's Kafka, Pulsar, whether it's something on Google Cloud like Cloud PubSub, etc., doesn't really matter. Here the idea is that the various services will actually send some message to say, okay, there's an order request that's been made. then a service that is interested in that kind of event, like the payment processor, will be able to pick up those events, those messages from the message broker and say, okay, I'm going to handle that one. I'm going to do something about it. Then I'm going to send another message, say, okay, I'm done. Next. Next, the shipper will take the new message that's been created, etc. So it's an interesting approach because I'll mention the pros and cons actually in the next slide. There are different technologies. Here I'm mentioning PubSub for Google Cloud, but all the other providers, open source providers, Kafka, Pulsar, etc., offer that kind of message broker fabric and tools to make it work. So the pros and cons for this approach, the services are more loosely coupled because they just know the kind of messages they can receive and send, and that's all they need to know. So that's the sole coupling that exists between the services, and the fact that they use the message broker, of course. The services can easily be changed or scaled independently. So, for example, maybe one of the components, one of the services may need to scale more because it's used more. So perhaps this service should be able to use more nodes in a Kubernetes cluster or something like this. And other services that are rarely used, they don't need the same, they don't have the same requirements in terms of bandwidth of computing nodes or VMs, etc. And since the services are also less coupled, when I say you can change a service, meaning that there can also be different teams, feature teams, working on each service pretty much independently, apart from agreeing on the contract or the format of the messages that are exchanged. There's no single point of failure. If at some point one service fails, oh, well, it's okay. When it'll be back up, it'll be able to pick the message that's waiting for it and treat that message. Events are also easy to use for whenever you want to extend the system. For example, you want to have new events for new scenarios. Well, it's just a new event that's going to be sent through the message bus, the message broker. If you want to have an additional service that plugs into the same event source for an existing message, it's also fairly straightforward to listen to the same topic and say, oh, there's this message, I'm interested in that one. So there may be several services subscribed to the same kind of message in the same topic. So it's usually easy to extend such a system and evolve as you add new microservices to your architecture. There are some cons. So usually it becomes harder to monitor. So compared to, of course, service to service, you can put breakpoints in your IDE and look at how things evolve. But here, with message passing, messages flowing through the system, it's hard to know who really picked that message or if that message to correspond to this or that transaction. So you have to be sure to put appropriate correlation IDs. When you do some logging as well, keep the same traces or remind about the correlation IDs, etc., in order to be able to filter among all the logs, all the traces, to know that all those executions of services are actually tied to the same business process execution. Errors, retries, timeouts, it's still something that's difficult because, well, you don't know what's really going to happen within the message broker. So how long should you wait once you've sent a message? If nothing else happens, it's still complicated. And also, what's interesting with this approach is that the actual behavior of the system is an emergent behavior of the design, of the architecture. But it's never written or captured, written down, you know, like in some flow chart or something like this that really describes the actual business process that's going on. And again, about how to ensure that the whole transaction is successful. So you'd have perhaps to have another service that tracks how things are going on, like from the first message of the beginning of the process up to the last message that says, okay, we've been successful throughout all the steps of the business process. So we had a fairly simple, linear, sequential example, but what happens when you've got something more complicated? There you have a real flow chart with branching with conditionals, potentially with loops and that kind of stuff, and also interacting with third-party APIs, not just the ones that you've deployed, your own microservices. So for example, here, you may have to check an inventory database to check the level of the stock. Depending on if you're out of stock or not, you may go into one branch or another. For example, if you're out of stock, you might have to call a third-party API to your supplier's API to replenish the stock, and then update your own database with the stock, potentially use another third-party service for notification, or you can also imagine that in some conditions, for example, if it's a big order, then you want to involve the sales team, etc. So no matter the details here, the idea is to keep in mind that the more complex your business process is going to be, the harder it is going to be for you to monitor and track what's going on. Another approach, that's our option 3, the one we're going to focus on today, it looks a little bit like the message broker in a way. So we still have the same components again, but this time, instead of a message broker, we'll have an orchestrator. An orchestrator will be a solution, a product, a tool that's going to explicitly call the various services. So it's kind of like our God service that calls each and everyone and tracks that everything goes smoothly. So this orchestrator, so it's not something new. I mean, there's been lots of orchestrators, open source ones, cloud provided ones, as well as perhaps some of you may know things like BPMN and other things. So the notion of workflows is not something new. An orchestrator is not something new. But yeah, the idea here is to have some kind of tool that's able to track and call each of the services of your business processes. So pros and cons of this approach. What I like about it is that the business flow is actually captured centrally in the sense that usually for those kind of tools, you've got somewhere a file that describes your business process. So it may be an XML file or YAML, JSON files, etc. But which means that you can also save that and store that in your source control, in Git or whatever you're using. It can be versioned. So some of the, I think I'm showing the benefits as well. Yeah, well, some of the cool things with that is that you can track, across the versions of your workflow. You can see what changes were made, what new components were added, etc. So there's a real history of what's been going on with that business process. Secondly, for example, when you have a new team member that joins, instead of having to figure out with the message broker, I see all those messages going through, but I don't know who is it going to actually invoke, who's going to be the next service that picks up that message, etc. It's not necessarily obvious, but here at least you're able to have a read at that artifact, that business process definition, and be able to make sense of the chaos of messages in event-driven architectures. Each step can be monitored. Usually with all those tools, you're able to say, okay, I'm at this step, at this stage of my workflow, of my business process. Errors, retries, timeouts, all the error handling aspects is actually now centralized because that's at the level of the workflow definition that you can say, okay, I want to wait for 10 seconds, but not more. I want to retry 5 times, potentially with an exponential backoff, etc. So you can also, another nice aspect that I didn't mention here is the fact that one service may be used in different contexts, different business transactions, and you may have different settings for error handling for each invocation for the different business processes. So it's more granular that way. Services are still independent, like in the event-driven approach, the choreography approach. In terms of cons, well, adding a new tool in that architecture, it means that it's a new tool that you have to learn and maintain and keep up to date, etc. It could also be a single point of failure, because if the orchestrator is down, nothing is going to happen, no business transaction. So it may be, or it may appear more brittle than a purely event-driven approach, a choreography approach. But usually, so for example, with cloud providers, usually they offer a certain service level agreement that ensure that the service shouldn't be down more than a few minutes per year or something like this. So it's usually not a problem. You may be losing the eventing flexibility when I told you about the fact that it's easy to add new events or subscribe to existing events. So that's where potentially it's less flexible in the sense that you have to update the different workflows to add new services, etc. Well, it's debatable, but it can be seen as a con. And again, how do you compensate for failed steps? And we'll mention that in the patterns in the third part of this talk. So when should you use choreography, orchestration? So direct service call, I would rule out that one and would focus on choreography or orchestration. And when should you use one or the other? Well, it depends, actually. And we'll also revisit that question later on as well. But one extra point I'd like to make here is that it doesn't mean that you have to use one exclusively and not use the other one. So in big systems, usually you'd have actually both systems. So for well-defined transactions, business processes, you would focus on an orchestrated approach because that's easier to handle. But for the bigger systems, maybe you would actually use event-driven approaches with messages that actually trigger orchestrated business processes. And that's probably the best pattern for bigger systems and bigger architectures. So let's talk a bit more about orchestration. And I'd like to mention something that's interesting. There's a new project, a new specification, which is part of the Cloud Native Computing Foundation. It's called Serverless Workflow. The idea is to define a vendor-neutral, open-source way of designing and defining business processes and workflows. So it's a specification. You've got SDKs for various languages to interact with the tools that are supported. You've got the runtimes that do or do not support the specification or not yet. Developer tooling to help with authoring workflows. So it's still something pretty new, and I haven't seen tools yet on the market that actually implement this, but it's something to keep an eye on. And it's also based on other specifications that are probably more popular right now, like, OpenAPI to describe your microservices API and REST APIs in particular. And also it's using the Cloud Events specification to define the events that are actually exchanged. It's still early to speak about this, so I just wanted to throw that so that you're aware of it, because we're still waiting for products, and even the one I'm going to cover doesn't offer support for serverless workflows. But you have to remember that specifications, it's like this little Venn diagram where you have a product that covers a certain ground of the spec, and the specification might cover some of the features of the product that you want to use, but not necessarily all the features of the product. So you have to be in the sweet spot in the middle of what's both supported by the product and the specification. And I'm going to focus, because in the demos I'm going to show you to illustrate the best practices and patterns, I'm going to use Google Cloud Workflows. So that's an orchestrator that is available as part of the Google Cloud offering. It's a tool to orchestrate APIs. So whether it's APIs that are hosted on Google Cloud own infrastructure, whether it's existing APIs offered on Google Cloud, like, let's say, machine learning APIs like text-to-speech and whatnot. Or you can also, of course, interact with external APIs, third-party APIs, like I mentioned earlier, SendGrid to send notifications and emails, etc. So all third-party APIs can be orchestrated. I'll just quickly show you what the tool actually looks like, but very briefly. So we're inside the Google Cloud Console, so you've got the dashboard to actually monitor what's going on for your workflows, number of executions, failures, etc. you're able to, so of course you see the list of all the workflows that are defined in your project. You can author the workflow with a YAML or JSON syntax. I'll come back to that in a moment. And you also have this visualization which offers the flow chart of your business process. So visually, you can also check that your business process matches the flow chart that is rendered there. Here, that's the screen to show the ongoing execution. So here, they have all succeeded and finished with the return output step, like this column that you see on the left. But if there are ongoing executions, you'd know what's going on, the ongoing execution, the current step. So it's easy to figure out what's going on, and also click on one execution to look at, okay, what's going on right now? We're at this step. Here are the inputs, outputs of each step of the workflow. You also have some screens to call and execute and launch a workflow execution. You can pass some data there and see the results afterwards, so the input, the output, and also see the logs that are associated with that particular execution. Not the logs for all the executions of your workflow, just that particular execution. And since I'm going to show you my little demos and samples using the workflow syntax, I'm going to give you some elements of what this syntax looks like. So for, well, pretty much the same use case as in the beginning of the presentation, I'm going to illustrate how you would write and author your workflow definition. So again, you've got a payment processor which calls a shipper service, which calls a notifier or interacts with a notifier. It's not direct calls, right? It's just that one happens after the other. So how do you do that? You define steps. So the stuff that are, the things that are highlighted in yellow there are the different steps of my workflow. Then you can see here that I can pass some input in input of a particular step and also return some output. And for example, so something I mentioned, I forgot to mention was steps are sequential as they are defined in the workflow in the order they are defined. But then you can branch and loop and do all kind of logic to go to one step and back to another step, etc. For example, here in this second step, I'm going to reference like the address that's returned by that processing payment service. So I'm able to parse and access the result, the outcome of previous step executions. Next, how do you actually call APIs, your own services, third-party APIs? So that's this part where you define, okay, I want to do a POST request on this URL for my service, and then again with the input and output. If the services are secured, it's pretty much declarative, especially with stuff that is hosted on Google Cloud, like your own services or APIs that are offered by Google Cloud. It's very declarative. You just say, okay, for this service, I'm going to use OpenID Connect to authenticate. Or if you use, like I mentioned, the machine learning APIs, for example, you would use OAuth2. And again, it would be auth type, OAuth2, that would be very declarative. So I don't have to really handle myself programmatically this aspect, this authentication aspect. And otherwise, if you have third-party APIs, you could also add right there, you could add things like headers, bearer tokens, etc. You could add that manually, but declaratively. Sometimes you know that some stuff is going to take some time, so you can introduce some sleep sequence. So here, I want to make a pause for 60 seconds. I can add, after each step, a specific log instruction so that I can see, if you remember the UI, I can see the logs for each workflow execution. And both sleep, log, etc. are part of the built-in functions that you can call within your workflow. And there are many available built-in functions for making HTTP calls, for error handling, for decoding text, JSON, etc. For error handling, so I'm going to combine several things here in that one example. So I can wrap my calls with try except block, and I get the exception here. And if there's indeed an exception that's called, I'm going to define some other steps, like a sub-workflow, if you will. And in that sub-workflow, I'm using another construct, which is switch, and with different conditions. So it's like a switch statement in programming languages, or like an improved if-else kind of switch, of conditional. And depending on, is it an HTTP error, is it a 404, something wasn't found, then I can go into different directions. So for example, there's a next instruction that tells me, it's a bit like a go-to, to say, go to the connection error step. Or I can also say, well, sorry, I have to return now because I can't do anything beyond that point. And if really none of the errors are handled, there's always the case of failing the workflow execution and raise the exception that was met and report that back in the UI and on the command line, etc. When you call some of the services, and you know those services are a bit flaky, they can fail at times, you can define the number of retries, you can define a backup strategy, so I'm going to wait 1 second, then maybe after, for the second call, I'm going to multiply that time by 2, so I'm going to wait 2 seconds, 4 seconds, 8 seconds, 16 seconds, up to a maximum of 60 seconds, for example. So there are default strategies for this. Here, I wanted to customize it, but there are some defaults that are available for retries. What else? You can have sub-workflows, so it's like functions or procedures. So you define, instead of the main workflow, you're going to define your own named sub-workflow, and it can also take parameters, and then you've got the steps as usual. Something, well, I'll briefly mention that. So although you can make HTTP calls, post, get, put, etc., there are also some connectors that simplify the interaction with some of the Google Cloud services. So for example, if I want to do some big data stuff with, here it's using the BigQuery data lake kind of tool, I can send some SQL queries, etc., but it's going to handle the connection with BigQuery. It's going to handle long-running operations and that kind of stuff. And there are connectors for various products and APIs. So for example, there are some cool ones, like if you want to interact with Google Sheets. So you can tie a workflow with a spreadsheet. And for example, with a colleague, we developed some demos that make that integration where you have a business user that's able to flip some Boolean value to go to the next step in the workflow, for example. So you can have some interactions between tools like sheets, forms, if you want to inject some data into your workflow, etc. So there are some cool use cases there. What else? Iterations. So you can iterate over data sets. For example, when I run a query on BigQuery, but I want to run the same query on different data sets, on different tables, I can have a for loop. But we also have the ability to do parallel iterations. So here I'm just saying, oh, run this for loop in parallel. And the variables that may be shared among the different parallel steps, I have to explicitly say, okay, those variables should be accessed in a safely manner so that there aren't two writers at the same time, etc. So in an atomic way. What else? Parallel steps. So you may have different branches that execute in parallel when you want to improve the throughput of your workflows. So again, it's about adding parallel and the shared variables and define the various branches of your workflow. And then under each high-level steps, so these are actually the branches, and you've got the steps per branch below the branch names. So that's it for the syntax. Then how you are going to deploy your workflow, you're either going to use the UI, potentially, but when you want to automate things, as you should, you can use the Workflows API directly, or you can use the gcloud command line tool to just deploy workflows. So you can deploy a workflow, you can execute a workflow, and you can also check a particular execution of workflow to know what's the current status. Okay, so that's about it. Now you've got all the syntax elements to understand the last part, which is about the patterns and best practices when you industrialize the usage of workflow products. So not just about Google Cloud Workflows, but it also applies to other products. But I'll illustrate with Google Cloud Workflows. So I said I would revisit the, the different approaches again. So you have to make a conscious choice. The direct calls approach that we covered in the beginning, it offers a simple architectures with handful of services that don't necessarily change often. So perhaps just doing some direct calls is fine. Or even sticking to a monolith, it's not bad if it's not a huge monolith. It's probably, you don't necessarily need to split the monolith till you really need it. Then the actual criteria for splitting it is different between, different projects. With the event-driven architecture, services are not closely related. They are more loosely coupled. Services are not necessarily executed in parallel or in a particular order. So they're kind of loosely going to be called at some point. And services can also exist in different bounded contexts. So that's the domain-driven design approach where, a service may be reused in different contexts, different business transactions, etc. And with the central orchestrator approach, the services are usually, at least you should use central orchestrators when the services are more closely related for a particular business context, business transaction. And usually, especially if you know there's a particular sequence or organization between those service calls, then it might be a good point, again, to use orchestration. And also a good rule of thumb, I would say, is that when you can actually describe your business processes in the form of a flowchart, then maybe it's a good hint that perhaps you should consider using an orchestrator in your architecture. So with the event-driven approach, so I'll show you a first demo here. So here, in this example, we are going to have an image processing pipeline. We're going to receive images in a cloud storage bucket. So I'm using another product that triggers workflow executions when there are some events happening in the cloud. So here, when there's a new file, I'm going to trigger my workflow execution. And what's going on here, so it may be perhaps a little bit confusing in a way, because you might think that because they are the four services there for watermarking the picture, resizing, adding labels, and filtering the pictures, they are stacked upon each other. It doesn't mean that they run in parallel, but actually it's a sequence of steps that we want to run, because one should run after the other. And then once we're good, we can output the resulting image in another bucket. So let me show you this. So all the code is, this one is in that particular GitHub project, but most of the other demos I'm going to show you, and I'll give a link to this repository at the end of the presentation. All the demos I'm going to show you, most of the demos are in this repository if you want to have a look later on. So I've got this service. Let me show you. So here the instructions are about how you're going to deploy the various services, but I want to show you especially the workflow bits and pieces. So here, or perhaps I show you the full YAML instead of the various steps. So the steps need to happen in a certain order. So before executing all the services that I want to call for my process, I'm going to filter the image if the image is safe to display. So if there's no pornography or picture with blood or things like that. So I'm going to use a service that is going to filter the images that I want to treat or not. So if it's safe, I'm using conditional there. I'm going to go to the next step, which is about adding labels to my pictures to know what's inside the picture with some machine learning API, etc. Then I also want to create a thumbnail for my picture, and then at the end I want to add the watermark and add things like the labels that have been recognized in my picture, like the objects, the things that have been recognized in the picture. And as you can see here, I have a sequential series of invocations of services, and they depend on previous ones. So that's why I'm using this sequential approach of steps, and in that case, it's easy to use a workflow for that. I forget if no, I'm going to mention that. I'll say a few words about those things where we actually replace the actual URLs later on as another best practice. So that was the first example here. Let me go to the next one. So I told you that when there's a big transaction and when something fails at some point, you may want to, so it's not necessarily a transaction like two-phase commit with a database or something like this, but it can be a workflow that lasts a long time. For example, on cloud workflows, an execution of a workflow can last up to a year. So we are speaking about potentially very long workflow executions. And here, for example, we have a service. You make an order. You've got a customer service that is going to prepare a credit offer. Then you may approve or reject that depending on the success of the creation of the approval of the credit. And in that case, you may want to make a step back and, for example, if the stuff that was ordered, the order was prepared, etc. So you have to undo that particular step. So the old approach with like banking systems, etc., was to create compensation operations to roll back what was done in a previous step if something fails at one point in the business transaction. So for this, it should be the example. Yeah, retries and sagas. So I have different versions of that scenario without compensations, etc. And I'm going to show you the final solution where we implement that saga pattern. That's the name of that pattern. Yeah, it's open. Is it the right one? Yes. So here, I'm creating a pending order. So I make the first call to a service. Then I'm going to call the credit service. But then potentially there may be some, that service may be flaky. So I may want to retry once, several times, etc. So I use the default strategy here. But if in return it tells me that there's some error, the service doesn't behave properly, etc., that's where I'm going to need to add compensation operations. And for that, I'm going to use the conditional, the switch construct, to say, okay, I want to reject the pending order to fix and to roll back what we did in previous steps. So here it's just one stage, but you could imagine processes with many, many steps, and you'd have to roll back a step. If you're close to the end, you may have to roll back step 3, 2, 1, etc. So you have to go back up the chain. Here it's a simple example. But then I'd have, the rejection is here, and otherwise, if it works, I'm going through the normal approval process, and otherwise, if it doesn't work, I'm going to reject and roll back in a way the previous step. What's next? Okay, yes, this one. So, well, it's a little bit the two examples there are two different scenarios. So it's not very readable, but bear with me for a second. What I'd like to illustrate here is a feature that I haven't mentioned, but it's when you need to have some kind of a human in the loop. Like, it's not just a technical, computer-driven business process, but you may have a human that approves or rejects something at one step in the workflow execution. So in that case, there's a callback feature that exists that you can take advantage of. So here it's, on Google Cloud Workflow, it's called callback, but other products have different concepts for looping humans in or potentially other third-party systems, etc. So it's not just for humans in the loop, but other systems in the loop. So I'm going to illustrate this with one example, the one on the left. So let's say, where's my demo? Let's say I'm using some, I should have changed this to Portuguese to French or English to Portuguese. I'm French, so I kept English to French. Let's say I'm calling an API, the Translate API from Google, to translate something from English into French. So I'm going to say, Porto Tech Hub is the best conference, okay? I'm going to call, under the hood, I'm going to call the machine learning API, and it's going to return something that says Porto Tech Hub est la meilleure conférence. I know there's some French-speaking persons in the room. Is it a correct French translation? It is the correct translation, thank you. But, you know, perhaps it's never 100% perfect, right, translations. So perhaps you won't have a human being validate or reject the translation. So in that case, so I have a workflow behind this, and I'm going to make a pause and wait for a human being to actually click a button to unpause my workflow and proceed with the answer from the human being, from the person. The person is going to reply with either validate or reject. So here, Nicolas said it was all right, so I'm going to click the green button, validate. And then my workflow was paused. Potentially, I could wait for like a year. But then I'm going to update the status of that translation and say, okay, this translation has been validated. So how can I implement something like this? So I think I need to close some of the tabs because I'm going to get lost. So this one, yeah, callback translation. No, let me show you the YAML directly. Is it open? Yeah, it's here. So here I'm going to call the translation API. So I would just need to use PT for Portuguese, of course. So it's very declarative, nothing programmable. And something I didn't mention is that I'm using, if you see the, well, it's too small, but I'm using the Firestore NoSQL database to actually store the ongoing translations. So I store the translation, French, English, and also the status, if it's been validated or not by a human being. So I'm updating, when I receive the translation, I'm updating that entry in the database. Then the important calls will be here, or steps. I'm creating a callback. At that point, it's actually creating an HTTP URL that can be called by another system, a front end, a third-party system, etc. Here I have a front end, so I was using, well, just some pure JavaScript, I think, in my demo. And I'm calling back that URL to say, okay, the person clicked the green button or the red button. So here, this URL becomes available, and the front end will call back that URL. And I have, I store the callback details in the database, etc. But the other important step is this one. That's where I say, now I want to wait. I'm going to make a pause in my workflow. And I'm waiting for that URL to be called by someone. And once this URL is called, I can resume the execution of the workflow. So again, it's really not just workflows that are purely computer-driven. You know, you can have humans in the loop or third-party systems in the loop to expand the execution of your workflow for more complex scenarios. The other example, but what time is it? Yeah, I should go a bit further. The other example is another approach, but I won't show it in details. It's you can have different workflows that actually cooperate together. For example, the one at the bottom is actually triggered somehow, but we want to wait for another event to happen in your architecture. So you may have another workflow that is triggered by another event, and that calls back your first initial workflow that was paused thanks to the callback feature. But I'll invite you to look more closely to that example, but that's the same techniques of creating callbacks and awaiting for callbacks to be called. Other advice, I showed you the syntax about how you can parallelize for loops or different branches that should run in parallel. Because the thing when you are using something like a workflow product is that you tend to do things very sequentially because things happen one step after the other. But then perhaps things can actually run in parallel or should run in parallel. For example, when you use BigQuery to analyze the Wikipedia data set, if you want to find the most popular pages of Wikipedia for a particular month, you might have to do a query for each table for each of the months you're interested in. So if you do it naively by declaring a step or doing a for loop, okay, where you're going to make the first query, wait 20 seconds for the first execution, second query, 20 seconds, third query, 20 seconds, etc., etc. So I think there's a problem of math because if you do 5 times 20, it's more than 1 minute, okay? So 1 minute and 40 seconds. But instead, if you know that those steps can actually be run in parallel, well, you'd better do it in parallel. So, because the 5 queries will run more or less in 20 seconds, and just 20 seconds for those 5 executions. So I can close this one and this one. So here, so yeah, that's the first example, which is not yet in parallel. Yes. So, no, it's already in parallel. So when you do a for loop, so I have the tables that are defined in a variable, and then I have to do a query for these 5 tables, tables of data set. So I would do a for loop. Okay, so I go through each of the tables, do the queries, but since they can be actually run in parallel, I should just say, hey, run this for loop in parallel and put the results in that shared variable. So be sure to, whenever you can, parallelize things that can be parallelized. And it's really very declarative. You just have to add parallel and potentially shared to add parallelization to your business executions. So I can close this one. Okay, almost done. Next one is going to be about how you can combine serverful workloads with serverless orchestration. So a tool like Google Cloud Workflows is fully managed by the cloud provider. So it runs, I mean, in terms of that there's a free tier, etc. But otherwise, how much it costs is actually proportional to the number of steps you're going through. But sometimes you may have computations that are heavy, that can't be run in just the span of a simple request to some kind of container or function, etc. So instead, you may want to use a virtual machine, a container, but it's something that may be expensive because usually you start a VM and it stays live and is waiting for work to be done, etc. And after the end of the month, when you receive the bill, it might be expensive because you should have shut it down and run it just on purpose when you need it and shut it down afterwards. And here with workflows, you can actually do IT automation, basically. You can automate your infrastructure. So for example, if I want to use a virtual machine to run a container or a virtual machine image, you can do that and actually use workflows to orchestrate the startup of the virtual machine, the shutdown of the virtual machine, etc. And the actual cost is going to be just the time that virtual machine has actually run. So the example, perhaps it's not the most exciting one to show, but I can call the Google Cloud compute engine product that runs VMs in Google Cloud. I can define, okay, I want this kind of machine that's defined in some, this type of machine in the particular zone, how I want to access it via the network. Here I want to say that I want to actually run a container on that virtual machine. The rights that the machine needs to run. And then I'm just going to call the invocation of that, the startup for that virtual machine, let it run. And perhaps I'm going to wait for some time or have another event, or perhaps run the actual workload to completion. And then I'm going to kill the virtual machine. Where is that? Here. I'm going to say, yeah, now you can safely stop and delete the virtual machine because I know the computation is done. So with workflows, which is a fully managed solution, you can orchestrate the execution of VMs so that they don't cost you too much, and you can automate your infrastructure also thanks to that. All right, what else do I have? Yeah, some quick words. So I'm over time, actually. And you can also, so I mentioned VMs, but there are also other things like cloud run jobs, which are containers that run to completion. But that's it's not using VMs, but that's another approach. I'll skip that one. And I'd like to finish with two last things, which is to try to adopt a GitOps-like approach when you manage the orchestration lifecycle and of your workflows. Having different environments, of course, like a staging environment. So you're going to push a change in your workflow definition. You're going to deploy a test workflow in staging. You run some potential tests here. And then if it works, you can then go to, you can deploy the final workflow in staging to be used in staging. But then once you're happy, you can make a pull request to the main branch in your Git repository, and then you merge the workflow. Again, you can redeploy a test version of that workflow to do some extra steps before you say, okay, now I deploy the real workflow. I'm sure it works both in staging and in prod, in the main branch, and then I'm going to be sure that things are going to work correctly. Here for the demo, which one is it? No, that's not this one. Here, for example, I used Cloud Build, which is you could use another CI/CD system. But here, what are the interesting parts? Well, I think I should show perhaps the YAML definition of the CI/CD, where I have different steps for doing like running the test workflows, deleting the test workflows, checking stuff. So I have different scenarios and different scripts. Okay, like let's say testing master that are going to check that my workflow works correctly. So it's a good practice. Well, no matter the details, just some bash script, but it's a good practice to have different environments. And one last thing about environments I'd like to mention, it's the fact that you have to plan for a multi-environment deployment. Also because if you remember in some of my examples, I had some tokens like replace URL. So depending on the environment you're in, you might have different URLs for the different versions of your services that you need to call. So for example, in staging, perhaps I have a dash staging name or URL for the service I need to call. But then how do you actually update the workflow? There are different approaches to use the correct URL. One approach is actually to use workflow arguments, because workflow execution can take some input arguments. So it's still the same workflow, but you use arguments parameterizing the actual workflow execution. You put them in some variables. But then the other approach is, which may be better, is having placeholders So instead of having just one workflow, you'd have one workflow for each environment, where potentially at build steps, you would replace the URLs with the right URLs for the services you want to invoke. So it's good to have that practice in mind. And I'm over time, so I'm not going to show it, but there are different approaches to that. And in the sample that is linked at the bottom here, I'm also showing an example, for example, with Terraform. So if you want to see how it's done with this approach. So that's about it. Thanks a lot for your attention. I'm still around after this talk. I don't know if I can take one question or it's really too much. Do you have any questions? One question in the front. Hello. Let's see. It's on.
Hi.
Hi.
Thanks for your presentation.
Thank you.
So in the beginning of the slides, you had an example of like a user buying something online. And in that example, you had some services, like I'm not sure what they were, but like purchasing, transaction, shipping. And sure, in the context of software, we can make those services loosely coupled, and we can claim that there's no single point of failure. But then in the real world, we will still, in the context of user experience, we will still have a single point of failure in reality, because if I'm buying something and those services fail, then I can buy it and the pipeline has failed in a way.
Yeah.
So to me, it seems like for that example, a direct calls could be the more appropriate approach, because it more closely resembles the real life behavior of, I don't know, the application or the context. So I'd like to know if you agree with this or disagree, and what things you are looking for when making a decision between direct calls, message broker, orchestrator, and yeah, that's it.
So I think there are different things to keep in mind. For example, is the actual workflow or business process something that's going to last for a long time? For example, in that case, maybe it's better to use an orchestrator, because you don't have a synchronous. You're not going to wait in that direct call approach necessarily within that area of the code, because it may be something that runs over weeks. So it's probably better to pause at that point in a way and resume the execution later on. So having the code directly there, do the direct calls, invocations, may be more brittle, because at some point, perhaps the server running that part of the code is going to be down. And then you need to ensure that you can resume back to the right state of that ongoing transaction once everything is back up. But for things that execute usually very rapidly, or especially stuff that is tied to the UI of your application, then direct calls usually is fine, because and that's actually what we do from the front end. Usually, you just call some APIs on the back end to launch the order, etc. So it's okay to have direct calls, but again, it depends on the scope, duration, and what other characteristics. So it might depend a lot on the actual workflow, but there are times where it's totally fine to do direct calls as well. You're welcome. One more question? No? So thanks a lot for your attention, and enjoy the rest of the conference. Obrigado.